Right. Good evening and a very warm welcome to each and every one of you joining us tonight. My name is Gerard de Klerk. I'm a SaiMechE Vaal Branch Committee member responsible for arranging events such as these ones. I see our participant numbers are picking up nicely, so I think we are ready to start. So the format for tonight's webinar will be as follows. After I've introduced our speaker, the presentation will start and will continue for a duration of approximately 20 minutes. We'll then provide an opportunity for questions afterwards. On the topic for tonight, whether you find yourself in the automotive, petrochemical, steel, mining, or fabrication industries, tonight's presentation applies to you. I believe that the information that Freddie shares tonight will benefit you as an end user, engineering contractor, or a fabricator. It will help you understand what the law expects of us, as well as how the implementation thereof will result in better quality, better control, and mutual trust between stakeholders. From SaiMechE's side, I'm proud to introduce to you our guest speaker, Freddie Engelbrecht. Now, I've come to know Freddie 13 years ago when I was still working in the pressure vessel design and fabrication industry. And even back then, he displayed his meticulous nature in terms of detailed inspection and detailed approach. So Freddie has been working for 16 years. He's got 16 years experience in the quality field as a QA/QC manager in the petrochemical and the energy sector. He started as a quality controller at a manufacturer and advanced through an AIA to become an inspector of pressurized equipment and API fixed equipment inspector. He has extensive experience with different types of fabrication and certification of equipment, taking into account and interpreting local legislation. He's also IPE and API certified. He specializes in fabrication and certification of pressure vessels, piping, and above ground storage tanks, be it local or international. So Freddie, welcome. Thank you very much, and over to you.
Thank you, Gerard, for the introduction. Yeah, I would like to thank everyone that's joining us tonight on this presentation. The introduction to ISO 3834, ensures sound welding from the first strike. So we can just move. So tonight, obviously, I will be your presenter. Gerard gave you some background. I am the QA/QC manager on the mechanical side here at Proconics. And yes, tonight we'll share some information on ISO 3834. So first of all, I want to share my first welding experience with you guys. I started as a boilermaker apprentice in the Polyfin in Sasolburg. So my first welding experience, the first time I took a welding electrode in my hand, closed my welding helmet, and struck my first arc. I knew I was hooked, as I couldn't get my electrode to release my test plate. This was my first fishing experience, as they would say in welding terminology. So then secondly, I want to show you a short introduction video on the most commonly used welding process, which is shielded metal arc welding, or in the British norms, it's manual metal arc welding, or as most of you guys would know it with a plain term as stick welding.
First, manual metal arc. Invented in Russia in 1888 and known in the States as shielded metal arc welding, or SMAW. It's the most versatile of arc processes, suitable for welding most ferrous and non-ferrous metals over a wide range of thicknesses. It can be used in all positions with reasonable ease. When an arc is struck between the coated electrode and the workpiece, they both melt at the surface to form a weld pool. The average temperature in the arc is 6,000 Celsius. The job of the flux, which melts instantly with the electrode and the parent metal, is to form gas and slag, which protects the weld pool from oxygen and nitrogen in the surrounding atmosphere. After welding, the slag cools and solidifies and has to be chipped off. The process allows only short lengths of weld to be produced before a new electrode has to be inserted into the holder. The variables which affect the final quality of the MMA weld are current, voltage, travel speed, polarity, and electrode type. So, among the pluses, MMA is ideal for field or workshop use. The kit is very portable and simple, and the process is all positional. On the downside, it requires a high skill factor. It's susceptible to slag inclusions, and it generates lots of unwanted fume.
So as you guys would have seen now in this video, that the welding process is not so easy if you try it for the very first time. So this is what you want to avoid and improve on. You can produce sound welding from these ones. So there's a lot of essential variables that you have to take into consideration. This is just to mention a few of them. So if your amperage is too low, your amperage is too high, your arc is too long, your arc is too short, and your travel speed is too slow, travel speed is too fast. This will all affect a bad weld. So finally, if you have all these essential variables and obtain the training, you will be able to produce a sound weld. So on this slide, by being certified to ISO 3834 standard with all the quality systems and measures in place, you would be able to produce a weld like one of these in these two photos that you've seen. So introduction to ISO 3834. This is an extraction out of ISO 3834 part 6. Welding is a special process. The quality of a weld is manufactured into the product and not inspected. This means that welding normally requires continuous control or that specific procedures to be followed, or both. So law is written in blood. The reason for this is that laws and standards are based on past experiences and failures and possibly fatalities of human lives. As you would see in the picture on your left-hand side, this is a vessel that erupted due to weld failure and caused the whole process plant to collapse and also caused fatalities. So weld failures doesn't only occur on pressure equipment, it could also occur on structural components. So as you would see here, this is a failure of a structure weld that could cause a whole structure failure to collapse and also take human lives. So the typical situation in South Africa with regards to ISO 3834 is you have to comply with the local legislations, which then refers you to the Occupational Health and Safety Act. And then for pressure vessels industry in South Africa, you have to comply with the PER, which is a pressure equipment regulation. And that also refers you to SANS 347, which is the categorization and conformity assessment criteria for all pressure equipment during the manufacture, modification, or repair of pressure equipment. It is also essential for the manufacturer to be ISO 3834 as one of the mandatory requirements in the local industries in South Africa. Another reason is for ISO 3834 is producing a quality product, especially when it comes to safety critical components. So for hazard categories 2, 3, and 4, in accordance with SANS 347, it normally requires the manufacturer to be certified to 3834. It also has involvement on the module of inspection that needs to be applied. So if you have the certification in place, the AIA involvement is less. This is a slide that just have the legal order of precedence, what I explained in the previous one. Obviously, you will start with the legislation, which refers you to acts and bills, the Occupational and Health and Safety Act. Then refers you to the regulations, and for pressure equipment, it's the pressure equipment regulations that then refers you to the safety standards, which is SANS 347 for the categorization of pressure equipment. You also have to comply to the design standard or fabrication standard that the equipment is fabricated to, and that entails that it requires that you have a certified quality system in place. May it be ISO 9001 or ISO 3834. And then finally, you'll comply with the user specification or client specifications. As you would see, all these legal requirements and standards you're not allowed to deviate from to conform to compliance. On the certified quality systems, if you do not have these in place, it will increase the module inspection as well as the AIA involvement. User specification, you're allowed to deviate only by means of concession, and only an acceptance from the client you might proceed to deviate from this. Why ISO 3834 certified company? The reason for certified quality systems is to build trust. Now, trust consists of a few elements as listed here below. Is reliance, sincerity, competence, credence, assurance, commitment, and integrity. We put controls and measures in place to ensure that we deliver a compliant final product. It is also important to continue building trust with your client. If we follow and maintain our quality systems, we create a culture to deliver a constant quality product every time. So benefits of implementing ISO 3834, the quality assurance, this is to improve the welding quality, management assurance that quality requirements will be met, compliance with construction requirements from the client. You want to improve service levels and skills within your company, and then deliver a final quality product. So reasons for being certified to ISO 3834 is cost, time savings, and safety. So first of all, you want to reduce repairs and reworks. Rework can cost the manufacturer up to 5 times the initial cost of production. And then you want to avoid gaps between QA, QC and the workshop floor so that everybody is aligned on what the project requirements is before the fabrication starts. You want to improve utilization of resources. If you limit your rework, then you can continue with actual production work. And then you want to manage the subcontractor to deliver the same quality as yourselves. You want to limit your client's downtime and production loss. And then finally, weld failures can lead to explosions, which can cause damage to production facilities and possible fatalities to human lives. Another reason for getting certified to ISO 3834 is for increased competitiveness in the market. First of all, you want to improve customer satisfaction. You want to boost your manufacturer's confidence, credibility, international recognition, and then competitive marketing advantage. So why promote compliance to ISO 3834? What we believe in doing. First of all, you want to improve quality and safety of a welded product. This will increase your level of competency within your company. Then you want to build quality into the product and not via inspection. You want to better your welding quality during the manufacturing process and not after. And then you want to maximize and use of local industry and domestic products and maintenance programs. As most of you would know, process facilities, most of the process facilities more than 30 years old, and failures tend to rise. And then finally, we want to improve our credibility in export and local markets. So inspection and testing method, visual and NEE examination. So visual examination is the most extensively used non-destructive examination method. So if you look at the picture on the top left, you will observe that there's blatant visual defects as there's arc strikes across the plate, as well as the painting was not cleaned around the welding area, so possible more defects will be observed in this area. On the picture at the top right, you will observe that there's a lack of fusion, there's a defect at the bottom of the weld, which is not visible to the surface. To pick up these type of defects, you will have to conduct non-destructive testing. The two most commonly used methods to detect this defect is radiograph testing as well as ultrasonic testing. It all depends on the thickness of the material. So rework and retesting will have to be done on this weld. This means additional cost, and which is not allowed for initially. So the rework, you will have to remove the weld. You have to conduct NDE to ensure that you have sound metal again, re-weld, and then conduct the same method of non-destructive testing that you picked up the defect up initially. So as part of ISO 3834 and fabrication standard, qualified procedures and qualified welders needs to be in place. This is to ensure that sound welding can be produced. So in the photos below, you will observe that on the top left, this is two bend tests conducted to qualify a procedure qualification record in accordance with SaiMechE section 9. On the top right, this is a sample for standard testing or to qualify procedure qualification record in accordance with SaiMechE 9. It gives you the quantities of mechanical tests as well as the location samples to be taken. The WQR stands for Welder Qualification Records. At the bottom left-hand corner, you will observe that there's two test pieces. The bigger test piece is to qualify the base metal range of the welder as well as process thickness. You also might want to qualify more than one process. Next to it, you will observe that there's a smaller diameter test piece. This is to qualify the minimum diameter of the welder. On this one, you will observe that there's 4 weldments in this test piece. The reason for this is, in accordance with the SaiMechE section 9, the weldment to be tested needs to be 150 millimeters long. Then on your right bottom, this is a possible defects that can arise on a fillet weld. As you would see, there's a pipe welded to a flange by means of a reinforced weld. Also has a partial penetration root weld. Defects that arise here was a lack of penetration in the root here, also a lack of sidewall fusion in the root that initiated into a crack of the reinforced weld. Also, you'll observe the area where micro hardness tests values will be taken. So ISO 3834, welding fabrication scheme. What is ISO 3834? ISO 3834 is a welding related as well as actual weld related. So first of all, it's a quality management system specific to welding processes and applicable to fusion welded metallic materials and independent of products manufactured. And then also it's a process control system to ensure weld integrity and the fulfillment of design intent. It also complements the ISO 9001 but can be used as a standalone system. Below is checks and balances to deliver a quality product. You'll start with control, define, measure, analyze, and approve. And so the cycle continues. The ISO 3834 system consists of 6 parts, which covers 3 levels of control. So part 1 is the criteria and selection of use for your company. So part 2 is your first level of control. That's the comprehensive quality requirements. That's more for pressure equipment, pressure vessels, pressure piping. Then part 3 is your second level of control. This is more for structures like bridges, but also have a high safety risk. Then part 4 is your final level of control. This is the elementary quality requirements. This is more for mass production, like the automotive industry, where the quality level is the least stringent. Then part 5 lists the standards and or specification which are necessary to conform and claim conformity to the quality requirements of ISO 3834. And then part 6 is the guidance on implementing ISO 3834 within your company. So this slide was taken out of ISO 3834 part 6, the typical manufacturing process. It consists of 3 stages. So the initial stage is your input requirements. That will take you over to your second stage, which is the control over manufacturing, which consists of the following elements: management responsibility, resource management, manufacture of welded product, measurement and analysis and improvement. And if all of this has been found acceptable, you move over to your third and final stage, which is compliance to complete a welded product to meet client requirements. So for ISO 3834, the following areas will be assessed during the certification process. There are 14 elements to be assessed. It starts from the tender phase through to the final delivery of product with the required quality records that needs to be accompanied. So ProGo is part of the Proconics group. This is our manufacturing site. So ProGo was the first manufacturer to be audited remotely by the SIW. The ProGo's readiness survey was conducted in the month of February, and due to the restrictions imposed by the COVID-19 pandemic, the SIW proposed to conduct a remote audit. This was surely a new and learning experience for both organizations. I hope this presentation was beneficial to you and that you were able to learn something from it. So if we can open the floor for some questions.
Freddie, we have one question already.
Okay.
The question is, where is the register found? And it's from Mandla. I just don't know which specific register. Do you maybe know?
Register, I'm not specified. If you can maybe define us more on the register that it requires.
What we can do is we can maybe allow Mandla to speak. Then
Okay.
let's quickly see if that will make it better. Mandla, can you hear us?
Attendance register.
You can just unmute himself.
No, sorry.
Elmarie, he's referring to the attendance register.
Attendance, okay.
Oh. Okay. The attendance register we will send out afterwards via SaiMechE.
Presentation so good there is no question.
If you want to maybe mention about the CPD points at this stage.
Yes, I think maybe just to, before you on, maybe ask a question because I'm sure you will have one. It's nice to see a few familiar faces on the attendance list. For CPD points, we've got an accreditation number that we can share with you guys. We can either send it out afterwards or we can share it on the group on the presentation now. But there is an accreditation number available that will result in 0.1 CPD points for tonight's session. So please make use of that. Neil, if you can maybe share the number, I can maybe give you just a chance to type it in the question, in the questions, and then it'll be available for everyone.
Oh, you know what? On the chat, there's a lot of.
Yeah. Okay. Yeah, I see. Yeah.
Okay.
Okay.
There it comes through. Good.
Freddie, do you want to address?
Yeah, I'll open them. Okay, so let's start. Is it from the bottom? So Lebanon, how do clients who necessarily do not have any welding experience protect themselves from potential issues from the manufacturing process? How do I know the QA processes do institute? That's why we produce that the manufacturer normally have being certified to accredited standard. Normally your ISO, your SAN standards, the two most familiar ones as I'm speaking now is the ISO 9001. And then more welding related will be your ISO 3834. If you work with accredited institution that is certified, that will be the most safety factor. The unknown ones is not widely used, and I don't think that they could conform to the standards that's required if they're not known. I hope that answered that one.
Share in die chat, dan sal ek hom net.
So, Freddie, I think if we go to the Q&A session or part section, in which way
Okay.
is ISO 3834 different from ISO 9001?
So ISO 9001 is a quality system in a whole, and that's related from safety and everything. As I said, if I can just give you the instruction out of 3834. So, well, as this special ISO 3834 is intended for fusion welding of materials and is application independent of products manufactured, where ISO 9001 can also cover non-welded products.
Okay, I think from Johan Meiber, how many companies have already implemented this standard?
I don't have the actual quantities with me, as there's more certification bodies. We have moved through the SIW, but there is like TUV and them as well that does the ISO 3834. I can try to pull the stats for you on manufacturer that is certified to the standard.
Okay, then when executing a repair, what is your view on removing the original hairs? Any consequences to be concerned about if this is not properly executed?
Yeah, this could have a major effect, especially on your type of chromoly materials. The heat affected zone also has an impact that dilutes into the new weld that's produced. So you want to remove all materials, but with the basic non-destructive testing, you won't be able, as you would do normally, a surface testing, which might be your magnetic particle testing or your liquid penetrant testing. You'll have to conduct some type of hardness testing or do a replication to ensure that the complete heat affected zone is removed, and could be quite costly.
Okay, the next one, just a general question. Who does ISO 3834 certification? My company has used ISO QAR for the ISO 9001 certification.
So the two known ones, I know there is more bodies. I think there's around about 5 bodies and is known in South Africa that does the certification. The only 2 known ones to me, and which is recognized by the type, like SASOLs and the ESCOMs, and these ones are the SAIW as well as the TUV.
Next question, what about other welding techniques?
So yeah, I haven't touched too much on other welding techniques. Every welding technique is got its own essential variables. If you go into, I'm just using ASME as it's most familiar to me, that you will get the essential variables to each process is listed in in SME Section 9. So you would go to QW 200 for your procedure qualifications and QW 300 for your welder qualification essential variables. Like I said, you have multiple processes. The most ones is gas tungsten arc welding, shielded metal arc welding, the gas metal arc welding, and then sub arc welding is the most known within South Africa.
Okay, question from Nikki. What is the average cost for a company to get ISO 3834 certification, and is that certification subject to specific welding individuals? Obviously, the welder produces the quality, so what happens if a company is ISO certified and the welder leaves the company?
Yeah, so the system is not related to the welder itself. As we know in the industry that welders come and go within the companies. What is the main structure it takes is your quality management system within your company, so that another individual welder can be drawn into your company and trained to your QMS system. And then, so it's not about the welder, it's about your quality management system. Where they are quite critical is with your responsible welding coordinator. So they don't want your quality personnel to come and go. That might affect your system, but not the welder itself. As a welder comes in, you need to train him to your quality management system.
Okay, another question from Mandla. On top of these standards, ISO and SANS 3834, we want AIA. How important is that?
So yeah, SANS 347 actually clearly states, so there's two scenarios. If you have a quality system and without a quality system. So the one without the quality system refers you to different modules of inspection. So that's why I say if you don't have the quality system, it increases the involvement of AIA. And by increasing that, it delays you on fabrication, because as a norm, you would give the AIA 24-hour notice, and this might slow down your manufacturing process, where if you have this quality management system in-house, you can control it yourself and have minimal AIA involvement, and your production must go much quicker.
Okay, next question from Anonymous. So ISO 3834 does not touch on the quality management of other welding techniques. I think you specified it actually does.
No, it does. It does to everyone. It's not specified to any specific. It's general in all types of welding. As I've mentioned, it's intended for fusion welding of metallic materials, only for metallic materials, but it's all welding process. For this presentation, I just used just the information's sake, the most commonly used welding process, but it's related to all metallic welding processes.
Okay. The next question from Denver. Why does having the certification relax AIA intervention? How does the piece of paper ensure that the QA/QC protocols are always applied or followed?
Yeah, that's actually quite a norm question. So there's not a piece of paper, because you've been audited by a certification body which is accredited to issue the certification. So you have the ability to in-house conduct your quality control. It doesn't always happen this way, because yeah, like you said, the lack of quality control inspectors could not appoint, but it is your company's responsibility to ensure that you apply this quality within your company, and you don't need the third party to ensure that your quality is done right.
Okay, next question from Guillaume. Why would you encourage engineering students to get exposed to the ISO 3834 specification on university level rather than only being exposed when entering the work environment?
I think it's very interesting as not everybody is known, and for the engineering students, not always known, as they don't know the fabrication side always and not exposed to that, what it's about. So for them getting involved to know that there's some quality systems that have control over the welding processes and to manage this, I think would benefit them in the long run, to ensure when they actually are a client or propose a part of a company like ourselves, having ProGo, to ensure that you have quality systems in place and that there is controls and measures to ensure that you deliver a quality product.
Then from Benedict, for the sake of standardization, how can the management systems be integrated?
So as I would say, it doesn't replace ISO 9001, it just complements it. It's an add-on system, but it can be used as a system on its own. But then it's only welding related, where you have the 9001 system, it complements that system, which has got a broader variety of things that you can certify to.
I'm just seeing there's currently no other questions. Let's maybe just see on the, wait, here's another one. SANS 3834 covers both shop and field work, and the AIA can issue both recommendations or NCRs to help manage the SANS 383 system.
Yeah, so it's definitely for shop and field. It doesn't relate to one specific area. It's how you control it, because you will have procedures in place and work instructions to say how your shop work is managed, the quality within your shop is managed, and you will have works instructions that say how work on site is managed. It shouldn't be the AIA to tell you that you're doing wrong. This is, if your quality system is up and running and been checked, you should know within your system that you are failing. The AIA is just there to show compliance to pressure equipment for category 2 and higher. As SAP and the involvement of AIA is not required.
Here is another question. How often do you renew welding certification?
So if I can understand you correctly, for welding certification, you qualify your PQR first time, so that will stay within your company for years to come. Only if you haven't covered all the essential variables. If I can use an example, if you didn't qualify your procedure qualification record initially with impact testing, and now you want to fabricate a piping that requires impact testing, you can do the additional testing and just do an amendment on the original PQR, but you do not change the original PQR. For welder qualification, in accordance with ASME Section 9, you have to renew your welder's qualification every 6 months. So the qualification he has with the process and the position that is welded, you have to have proof by means of non-destructive testing that welder can still produce that weldment with that process.
Okay, from Anonymous, how is SANS 3834 applied to structural welding and not just piping that are regulated?
So why it's applicable, the only reason is, like something for say, you don't have the AI involvement, but the integrity, it still has a big safety factor, as the structure could fail, and buildings are all structures, and there's human lives that could also, if the structure collapses, it could cause fatalities. And that's why it's not only pressure containing, it's all safety factor related.
Question from Edward. To what level do major companies such as Eskom and Sasol credit manufacturers with ISO 3834 when assigning the necessary inspection modules, as this is specified by the designer? Do they accept lower AIA involvement?
Yeah, so Sasol, out of experience, I know they don't lack, as they see all piping to be hazard category 3, as well as they want module G full inspection on there. For the Escoms and those, I think they apply, because it's a manufacturer responsibility to conduct the hazard category, which then refers you to the module, and they accept compliance with this in-house. I know that Mittal also requires you to be certified to ISO 3834, but they don't enforce higher module inspections.
And then a question from Richard. Where and when does one report deviations to QMS of a fabricator that have a significant impact to the client?
Yeah, so first of all, you need to see with who was the certification body that certified him, and I would report it directly to the certification body that re-audit or need to be checked, and maybe if they don't comply, that the certification can be revoked.
Okay. Another question, if my company has ISO 9001, is there a strong argument to get the 3834 as well?
I would say if you're a company that manufactures where welding is your biggest part, I would strongly recommend to get ISO 3834 Part 2 certified, as it would open more doors for you as clients and end users are known to this standard, and set it as the minimum requirements for them to give work out to the manufacturers.
Okay, another question from Anonymous. What other accreditations are used, or is SANS 3834 accreditation the norm?
For welding, to metallic welding, ISO 3834 is the norm. With our industries, there might be some other standards, but not within our local, not the PER also, and the 7347 all refers you to ISO 3834.
Okay, then from Denver Moodley, Sasol have changed that view in the update of SP 40-05A, Cat 3 no longer standard for piping.
Okay, that's good news, but I just want to ensure, I'll just have to confirm if regarding the bulletin been removed, the Sasol bulletin, engineering bulletin on that.
Denver says piping approach only, conformity assessment still in accordance with module G, work in progress.
Perfect. It's nice to know.
Is SANS 3834 limited to only a selection of materials?
No, it's, as long as it's metallic. You can't do non-metallic in accordance with this. There's no, it's listed to all materials. You also apply to your stereo, your design and fabrication standards, which will allow the materials for that standard.
Okay, it looks like that is all the questions.
Good, wonderful. Thank you very much, Freddie. There's been a lot of activity on the questions. Thank you very much for answering all of those, and thank you very much to the participants for participating. I see there's one last question, Elmarie, that we can maybe take. What's the latest version of the standard, Freddie? Is the question from
ISO 3834.
Yes.
Okay, if you can just.
Well, I think we'll take these last two questions, and then we'll close the evening off. So that's the one. While you're looking for that latest standard,
I actually have it open, yeah, 100%.
I would like to add also that all of the questions that we've answered now, Freddie will double check all the answers, because I was trying to type in everything, but then we will distribute it afterwards after he has quality checked the answers.
Good, wonderful. Freddie, have you?
Yeah, so the latest one I have, so remember this is dual certified, so it's recognized within SANS as well as ISO. So the SANS 3834 is 2006 edition 2, and then for the ISO 3834 it's 2005 also edition 2.
Good. Then the last question that we'll be taking for the night, if work done for your company was done by a manufacturer who was found to be deviating from the QMS, would you have to get recertification done for the welded components?
Just rephrase the question, sorry.
Okay. If work done for your company was done by a manufacturer who was found to be deviating from their QMS, would you have to get recertification done for the welded components?
No, I wouldn't say that, but I will definitely report that issue as it's if they don't follow the quality management system. If it's a weld failure, that's a norm. You have procedures in place and work instructions in place how to manage weld failures. But if they're deviating from the QMS, I would definitely report it or take it further to a certification body.
Thank you very much, Freddie. Guys, thank you very much for the participation tonight. I think to see so much activity by participants, it really adds so much more value to a night like this. So thank you for that. And for those of you joining us tonight that are not SaiMechE members, please consider signing up to ensure that you are notified of any and all similar events in the future. My hope is that one of these days we'll see each other face to face and not necessarily across a screen in the not too distant future. So thank you very much for attending and have a wonderful evening.
Thank you, everybody.
Thank you, guys.